Okay, in this video we're going to have a look at some exact values. Now, you might choose to learn off the table, or you can learn the two triangles. So with our two triangles, we have the 45, which is our 1, 1, root 2, and then we have our 60, 30. So we've got 1, root 3, and 2. So you can learn those two triangles and then come up with all of the ones that you want from there, because we really focus on our 30, 45, and 60 angles, and that's where we base our exact values on. Then we have the zeros and the 180, etc. So we've got sine is 2 pi on 3. So we want to know whereabouts that is going to fit in our unit circle. So 2 pi on 3, sometimes it is easier to change it to degrees. Some students find that a little bit easier to work out whereabouts that is. So it is 120 degrees. So we know that it's bigger than 90, smaller than 180, so we can put our line in here. Now, if we're at 120, that means that we've got 60 degrees till we get to the horizontal. We always base it off the horizontal. If we base it off the vertical, the angle, then we have to switch. Sine goes to cos, cos goes to sine. But if we're going off the horizontal, we still stay with sine. So it's going to be the equivalent of sine of 60, because it's in that quadrant and sine is positive in that quadrant. Now, sine of 60, we come up here, we want opposite over hypotenuse. So it's going to be root 3 on 2. If we've got cos of 3 pi on 4, so we know that that is also going to feature in this quadrant over here, because we've got our 2 pi on 4 and 4 pi on 4 there. So it's going to be halfway, which means it is the 45 degrees. Obviously my diagram is not to scale. So we've got a 45 degree one. In that quadrant, cos is negative, so it's going to be the same as cos, negative of cos 45. So then we come over to our 45 triangle. Cos is adjacent over hypotenuse, so we've got 1 on root 2. Now, in the current textbooks, they leave it as 1 on root 2. If you're looking at anything that's a little bit older, we used to make sure we didn't have a surd on the bottom, and so that would be written as root 2 on 2. So you may see that from time to time, depending what you're looking at. I find the textbook can sometimes be a little bit inconsistent, but we've kind of gone to where we're not too concerned about changing that to having no surd on the bottom. Now the last one is tan of 5 pi on 6. So thinking about where that will feature. So I know that if I go the whole way around, it's 6 pi on 6. So I'm going to redraw that and put my 6 pi on 6 there. But I haven't gotten the whole way, so this must be in there, pi on 6. Now I know that pi on 6 is 30. The other option is I can change that to degrees. So 6 times 180, 5 times 180. Oh, that's the 6 pi on 6. This is my 5 pi on 6. So 5 times 180 divided by 6 gives me 150. So 150 I know that is there. So the 30 degrees is there, like I already worked out. So now that I know it's the 30 and I'm looking for tan, and in that quadrant I know that tan is negative, so it's going to be the equivalent. So my tan of 5 pi on 6 is going to be the equivalent of negative tan of pi on 6, or negative tan of 30. So I go up to my triangle, my 30 is up here, so my tan is opposite over adjacent. So I've got 1 on root 3 as my answer. And like I said before, if you're looking at some older textbooks, etc., they might make sure there's no surd on the bottom and write that as root 3 on 3. Okay, hopefully that helps you with your exact values. And then in the next video, we will have a look at some graphing of functions. So that is the next thing that we'll be moving on to.